Today we're looking at polynomials. In order to define a polynomial, we need to know what a monomial is, and it's simply multiplication of variables and numbers as long as there are no negative exponents. A monomial cannot have division, and a negative exponent would move it to the denominator. A polynomial is the sum or difference of monomials. You have probably heard of binomials, the sum or difference of two monomials, and trinomials, the sum or difference of three monomials. Those are special types of polynomials. Once you have four or more monomials added or subtracted together, it's simply called a polynomial. Standard form is really important. If a polynomial is written with the highest power on down, then it's easier for all of us to kind of be on the same page when we're expressing our answers. The degree of a polynomial is simply the highest power on any term within the polynomial. If it's written in standard form, it would be the highest power on the first term. Coefficient is a term you should be familiar with. It is the number that is multiplied by a variable. The leading coefficient, again, if the polynomial is in standard form, the leading coefficient is the first one. Otherwise, it's the coefficient on the term with the highest degree. And we're also going to take a look at how to cube binomials. These are the shortcut rules, and I will go over what I think is kind of an easier way to get your binomials raised to a power than what's written here in front of you. All right, our goal today is to apply polynomials to problem solving. Before we get there, we need to know how to work with polynomials. First, we're going to rewrite this in standard form. A common error students make when rewriting it in standard form is dropping the subtraction sign on the first term. What actually happens is it turns into a negative sign. So you have to keep the sign on each term as you rewrite them. Minus 3x squared plus 7x plus 1. Once it's in standard form, the degree is easy to find. It is the power on the first term. So the degree of this polynomial is 4, and the leading coefficient is the coefficient on the first term. In our case, we are multiplying that x to the fourth by a -1, so that becomes our leading coefficient. Adding and subtracting polynomials you should be familiar with. I like to find the one with the highest power first and combine those. What happens is my answer will automatically be in standard form. -7x squared does not have any like terms. X plus 5x gives us a total of 6x plus 1. For subtraction, what you want to do is distribute the negative sign first and then add. Adding is always easier than subtracting. Multiplying is always easier than dividing. So if you can change your subtraction to addition, you will 9 times out of 10 get the right answer, versus a lot of students mess up if they try to subtract without distributing that negative sign. Now we have 7x cubed minus 10x cubed for a -3x cubed. 3x squared plus 2x squared for a total of 5x squared. The -4x doesn't have any like terms, and neither does our +4. For this example, we want to work on the inside out. I'm going to distribute my negative sign again. I'm going to combine the like terms on the inside of the brackets. 8x minus 10x is -2x, minus 3x is -5x. Then we can distribute that negative sign on the outside of the brackets for a total of 11x. Multiplying, I'm sure a lot of you are familiar with FOIL. FOIL only works specifically with binomials. So on example B, where we have a trinomial, we cannot FOIL. We just use distributive property. So I'm going to start by talking about distributive property on this one as well. So for those of you that like one way to remember how to do things, you can just use distributive property and you don't have to worry about when can you FOIL and when can't you. Distributing my x to both pieces in the second set of parentheses. And then I'm going to distribute my 4 to both pieces in the second set of parentheses. We end up with some like terms with our -9x and our +4x, which gives us a total of -5x. As mentioned on part B, we cannot FOIL, so I'm going to distribute again, distributing my 6x squared to everything in the second set of parentheses. Then I will distribute my 1 to everything in the second set of parentheses. And finally, I will distribute my x to everything in the second set of parentheses. And then I will find my like terms. My 18x cubed has the highest power and no like terms. And then I have negative 30x squared plus 3x squared, which gives me a negative 27x squared. 3x minus 5x is negative 2x, with my negative 5 with no like terms. The next skill we're going to learn is how to cube binomials. When we get into higher powers, I'm going to talk about something called Pascal's triangle, which you may have seen in Algebra 2, you may not have. For now, we just need to know one row since we're specifically just cubing binomials, and the row of Pascal's triangle we need to know is 1, 3, 3, 1. We're going to create a little chart around those coefficients. We need 3 rows. When you expand binomials, you will always need 3 rows. 1 is for the coefficients, 1 row is for the first term, and 1 row is for the second term. Now what we're going to do is take that first term in the binomial and raise it to the highest power. And then we're going to subtract the powers until we get to x to the 0 power, which is 1. I like to just leave that box empty because what we're going to do is multiply vertically, and multiplication by 1 doesn't change anything. Then we're going to take that second term and we start on the end with the highest power and work our way down towards the beginning. Again, that first box will be empty or a 1 if you feel the need to fill it. As I mentioned, we're going to multiply vertically, so 1 times x cubed. And then we will add to the next term. 3 times 5 is 15x squared. 5 squared is 25 times 3 is 75x, plus 5 cubed is 125 times 1. This is the total we would get if we chose to multiply this the long way. As a reminder, if we wanted to expand this the long way, we cannot distribute a power into a sum or a difference. We would have to multiply x plus 5 by x plus 5 first, and then that answer we would multiply by x plus 5 again. So it would be a lot of distributing. It is possible to do that. If you don't like the box method, you can go ahead and multiply it out. But as I mentioned, we will be getting into binomials with higher powers. So this chart is much, much easier to use as you get into something like the 7th power. Instead of multiplying a binomial by itself 7 times, this chart gives us the answer pretty quickly. For those of you who aren't real comfortable with it yet, let's take a look at how this works one more time. We have 3 rows, and we will need 4 columns for those 4 coefficients, which will always be the same when we raise it to the 3rd power. The coefficients when we raise it to the 3rd power are 1, 3, 3, 1. Starting with the first term, now we have to keep 2x in parentheses because we will have to raise both the 2 and the x to the power. Of course, the first power we don't need to worry about. Now we have a negative sign. We have to keep that with the 4y as well, because depending on the power, that will change the sign on our answer. Dropping that power as we go forward and leaving that first box empty. This one, because we have some evaluating to do with those powers, I will do that first and then we'll multiply all of those values together. Our first term we're going to get simplified right away because we're just multiplying by 1. We will raise 2 to the 3rd power, which gives us 8, as well as x to the 3rd power. I'm going to use plus signs on all of these, and we'll figure out if it's positive or negative when we simplify on our last step. We have 3 times 2 squared x squared times negative 4y plus another 3 times 2x. Negative 4 squared is 16y squared. And our last term, when we cube that negative 4, we get negative 64y cubed. Of course, multiplying by that 1 doesn't change anything. Those middle two terms we need to simplify. 8x cubed minus, because we have a negative 4, negative 4 times 4 is negative 16 times 3 is negative 48, x squared y, plus, because we have all positive values, 6 times 16 is 96, xy squared, minus 64y cubed. I have two error analysis. These are ones where students really are tempted to make mistakes. So find the mistakes that I make on these two problems, and we'll start off in class talking about where the errors were made and why these are such common mistakes. Part A, combining my like terms, I have negative 9n squared minus 6n squared is negative 15n squared. 5n plus 12n is 17n, and 1 minus 8 is negative 7. For part B, I'm going to distribute my power. 5 cubed is 125 times x cubed, minus 2 cubed is 8. Again, I made mistakes on both of these. Find and fix those mistakes, and we'll talk about those in class.